Alright, this is 015B acceleration lab sheet, and this one is a little more simple, but it's going to be fun. So let's talk about the expectations. First thing, of course, type your name. Make sure that's there. And you want to look at your materials. This is where you would double check that you have everything you need. So you should have some kind of flat board, rubber band, toy skateboard, calculator, which you could use like a tab for calculating on the Chromebook or something. 3 washers or these little metal pieces that I might give you, and a meter stick. Okay, so first thing always is read the procedure. Procedure is a fancy way on a science lab of just telling you this is what you're going to do. And if you're wise, you read it step by step very carefully. And if you make a mistake in one of the steps, that's where later you get the wrong answer or it gets goofed up. And that used to be what happened to me when I was in school. So I learned to really read carefully. All right, so the first thing is make a ramp from the board and a wooden block. This is probably going to be a textbook, but basically you're just going to go ahead and take some kind of book or block or whatever, and then you're going to elevate the board so it's kind of diagonal like that with the book under here, okay? And you roll the skateboard down the ramp. So test it out, test out that rolling thing. Some of you might have a skateboard, some of you might have a little car or something, you'll see. And then you use the meter stick to measure how far the skateboard travels and record. So you're going to do your first trial. Now, trial is a fancy way of saying the first time you did it, okay? So let's say you have the skateboard and you have no metal pieces on it, okay? So that's 0. So you tried it one time and then you got your meter stick out, and once the car stopped, it went, let's say, half a meter. So you would go ahead, click in the box, and you would type 0.5 M, okay? M for meter. All right, then you would do it again. Still, you're going to go ahead and for 5 times, you're going to do the skateboard or whatever with no washers. So the first time is 0.5 meters. Whoa, the second time you did it, it was 0.4 meters. Okay, was that like an error, or did the first time you gave it a little push? What happened? Okay, you try it again, third trial, okay? And at this point, oh, it's 0.5 meters again. Well, that's awesome. And as you keep going up, it's 0.5 meters again. All right, so at this point, maybe you and your partner had a little goof up, and you can say, well, that was a goof up because I'm seeing all the other times I did it, it's 0.5, okay? And then you would go ahead and do that. And then once you have the 0.5 in there again, now here, this is where you would average it, okay? So you know from math, if you're going to average a set of numbers, like a set of test grades or whatever, you would add up each of them, so 0.5 plus 0.4 plus 0.5 plus 0.5 plus 0.5, okay? And then when you get that number, then you would go ahead and you would divide it by how many times you did it, and you did it 5 times, okay? And then boom, that's where you put your average right here, okay? Now it might be centimeters, the whole meter stick thing. If you're looking at it, especially if it's a low number, you definitely could go ahead and just make sure you're typing this in centimeters. That's fine too. So basically just see how far the toy car goes, or the toy skateboard thing, okay? Now next time you're going to go, but let's go back to the directions, right? Alright, so it says repeat steps 2 and 3 for a total of 5 trials. Okay, now that was what I just showed you, alright? Now, we go down to step 5. Use a rubber band to attach 1 washer to the skateboard. Okay, so you go ahead, you get that piece of metal, might be a screw, might be a washer, whatever that you have in your box, and then you go ahead and tighten it up so it doesn't fall off. Okay, now we're going to do 1 washer. Okay, we're going to do it 5 times. Alright, so let's say this time, well, I'm not going to give it away. Alright, you might be surprised. When you do it, you're going to see, just like you did up here, that you should be able to get the same basic distances each time. That's how far it went before the skateboard just rolled to a stop. And again, get the average, go ahead, what's your average, and put it here. Okay, so that you're going to add up all the distances, divide by 5 because you did it 5 times. Alright, back to the directions. Alright, so if I'm looking at this right, then you go ahead and you add another washer or metal piece, okay? And you go ahead and repeat the steps. So now we're going to do 2, alright? And you would say, okay, well, the first time it was this, and second time that, third time that, fourth time that, fifth time that. You get the idea. Go ahead, back to the directions. Do the same thing. Add a 3rd washer, okay? So now we go ahead, 3rd washer. So you guys see that you're going to use the row to do each of the washer trials, okay? To make sure that your numbers are coming out right and somebody's not just like, flicking the thing a little too hard. You're going to have your averages here. Now, once you average up each of the rows, okay, so the averages from these trials for that one, the second average is from these, the third average is from these, and the fourth average is from these, okay? Now you're going to go ahead and move to your second sheet. Okay, now let's read the directions for this. It says data analysis, that we're going to figure out what happened with the trials by graphing the data using a bar graph. All right, it says remember to title and label your graph. Okay, so especially in high school when you go to labs, these things will take away points if you don't do them. It might be 5 points, 10 points. Okay, so title of the graph, you could go ahead and label it, skateboard acceleration graph, whatever you want to title it. Now over here we have on the y-axis average distance, okay? And this is important. You're going to find this out later that the dependent variable goes on the y-axis. Dependent just means it needs to see what happened with the x-axis to see what's going to happen with it. Okay, so obviously if you have your independent variable is 0, so let's say that you had no washers, when you did it, how far did that make the average distance go? When you had 1 washer, how far did it make the average distance go? 2 washers. Okay. Now to do this, I kind of played with some ideas, but I think the best thing to do is let's say that it went 5 centimeters, okay, for 0 washers. So you would go ahead, click on the third box here, and then go up like this. And I guess I just said 5, right? So let me see if I can count right. Let's see, that's 4. There we go. I think that's 5. Okay. So you click that. You're highlighting all of those, right? Because it's right centered under the 0. Now you go up here. This is what they call fill. This is like a fill color, okay? Just choose a color for the first one. Let's say we're going to make it green, okay? And do the same thing for the 1 washer thing. Let's say this time I'm just making it up. Let's say it went that far, okay? Go ahead, go up to the fill color. Let's say we're going to make that, I don't know, pink, whatever. So you can see as you're going along here, let's see if I can get that to work. No, I don't want to mess with that. As you're going along, it can look pretty cool. All right, and use the same deal. Okay. All right, let's see what's next. So we just did this page. There's no other questions here. It gives you some tips. All right, third page, now we have some questions. Conclusions. All right, this is where you've done the lab, you've analyzed the data, you've graphed it, you can see how it looks. You can probably see a trend based on how tall the bars are for each of the washers. Number 1, how does increasing mass affect the motion of objects? Explain your answer using data from your experiment. Okay, so this is where you would go ahead and you would make the claim again. You're going to say, well, I think increasing mass is going to make the motion of the objects last longer, or it's going to make it not last as long. The more mass we add, my claim is going to be that it's going to decrease how far the object moves, okay? But you have to explain using your answer. You would say, according to our experiment, the more washers we added, this is what happened, okay? All right, number 2, predict how far the skateboard would roll if you added 5 washers, because I don't think we did that, right? We were just going ahead and doing 3 washers. So 5 washers. All right, explain your answer using evidence from the experiment. Same thing again. Now this is where you would say the trend. As I looked at my graph, according to the graph of our data, as we added more washers, the motion was less and less every time, or the motion was the same, or the motion was more and more every time. All right, so you can be able to explain that you think once I add 5 washers, you can predict what's going to happen because you've seen the trend of the bars on the bar graph. All right, last question. Acceleration is a change in velocity. I love that when they give you information in a question. It's to help you be able to answer it. So acceleration is a change in velocity. Remember, velocity is speed and direction, but the point being is just it's a change in the speed. It's not the same speed. This may be a change in speed or direction. What effect does mass have on acceleration? Same thing. This is actually a very similar question to the ones above in a different way. It's just saying, now that you do have more mass or less mass based on your bar graph, did that make the skateboard speed up faster? Did it allow the skateboard to gain more speed so that it could go further? Or, did it mean that it actually had less acceleration? It sped up more slowly so it didn't go as far. And again, that's the data from your experiment. You could actually say, well, now you know what more mass will do to the distance that it can go. And that's pretty much it. So have fun.